Welcome to the world of physics. So we were dealing about our chapter magnetism. We have studied some of the common properties of magnet. The last class we were discussing about the test for magnetism and we have seen some general terms for magnetism. I hope you have completed your homework. I hope you have read the portions very well. Today we are going to discuss about magnetic field. What is magnetic field? So, when we have learned about gravitational force, we have seen that Earth is attracting the materials towards it. We have called them as a non-contact force or force at a distance. In that non-contact force, we have learned about magnets. Magnetic force is also one of the examples for non-contact force. So we can say that magnets are attracting magnetic properties towards them. It means magnet is having an attractive force. Magnet is having a force of attraction. So the attraction by the magnet or the force by which magnet is attracting magnetic materials are called magnetic force. Magnetic force. The force by which magnets attracts the magnetic materials are called magnetic force. Now, suppose if we are considering a bar magnet, we know that there is no types of poles are there. Suppose I am going to take an iron needle and I am going to keep near to the iron needle, near to the magnet. Suddenly you know that this iron will be attracted. That means there is a magnetic force of attraction is experienced by the iron, so that it will be suddenly attracted. If I increase the distance, suppose I have the iron somewhere here very far away, then will there be any attraction? There will not be any attraction. That means that much distance the magnetic force cannot be experienced. So surely there should be a certain area or certain region around the magnet where we can experience magnetic field can be there. That means suppose I can just say that this much area I can experience magnetic force. It means if I keep the magnetic materials inside this area, then only it will be attracted by the magnet, and if it is out of this area, it will not be attracted by the magnet. So, magnetic field, that's the topic today. Magnetic field means the area around a magnet or the region around a magnet where we can experience magnetic force. So, what is magnetic field? The area or a region around a magnet where we can experience magnetic force of attraction is called as magnetic field. And what is the speciality of this magnetic field? Magnetic field will reduce when the distance is increased. When the distance is increasing, the magnetic field is going to be reduced or decreasing. So that is one of the property of the magnetic field. Again, we can say that another one thing is that magnetic field, already we have discussed about poles. The magnetic field or magnetic forces are maximum at the poles. Now, we know that these magnetic fields are there. We do not know, it is not able to see, no? So, magnetic field will be there. There will be some characteristics of this magnetic field, no? So, if we are speaking about magnetic field, are we able to diagrammatically represent this magnetic field? That's what we are going to discuss next. Magnetic field is represented used by a curved lines is called magnetic field of lines. Magnetic lines of force. Okay, so magnetic lines of force. So what is magnetic lines of force? This field we are going to represent it with curved lines. For example, you can just look at your page number 86. On page number 86, one activity 6 is given to study the magnetic field around a bar magnet. So first we can discuss that one. Now we are going to discuss the study of a bar magnet. So magnetic lines of force means what? The diagrammatic representation of magnetic field is called magnetic lines of forces. Now we are going to discuss about the magnetic lines of forces. Without diagram, we can do that means I have extra north and south called a bar magnet, and it is kept on a paper, and this paper is filled with iron filings. Okay, now what I will do, I will just note on the paper. When I am noting on the paper, suddenly these iron filings will have a certain arrangement, just like shown in page number 86, figure 7.10. There will be some arrangement will be there. That means there will be some arrangement like this, some density will be higher here. Here will not be much iron filings will not be there. Here, like this, you can able to see. So this is how magnetic field occurs. And in laboratory we have compasses, magnetic compasses. I think when we have discussed about the previous classes on page number 82, we have discussed about magnetic compass. There I have seen that we have seen that it is just like a watch dial. There will be an arrow, a small point will be there. This is actually a magnet which is having north and south pole, and we know that it is able to rotate at any direction. Okay, so how we can trace out this magnetic field lines of a bar magnet? That's what we are going to learn. The next one is on page number 86, activity 7. So if you want to trace the magnetic lines of forces, you need an external bar magnet along with a magnetic compass. Magnetic compass. This is magnetic compass. So I am going to take a external bar magnet and A4 size paper I am considering, and on the A4 size paper at the middle of the paper I am going to place the bar magnet. This much is clear now. What is the next step? There will be north and south pole will be there. I have marked the north and south pole. Then we will take the outline of this magnet. Then at one pole I am going to place the magnetic compass here. So as I said that this will be every suspended bar magnet will be always giving the north-south direction. Right now. Now here the lines of forces are there. That lines of forces means magnetic field line. So we are going to plot the magnetic field line, and we are going to find out from where to where, which direction the lines of forces are traveling. So I am going to take the compass here, and then I will observe that the compass is showing like this. Arrow is going to show one reflection. So I will keep one dot here. Now I will take out this compass, keep here. Then I will show the arrow is showing like this reflection. I will keep here. Then again I will keep the compass here. Then it will be showing like this reflection. Then again if I keep here, it will show towards the south pole. So everywhere I have marked. This was the pointer. Then I am going to join this line. So this is called magnetic field line. And what will be the direction? Direction will be the direction of the argument of the magnetic compass. So it's clear that the magnetic lines of force, the field will be originating from north pole, and it is traveling to south pole. It is traveling to south pole. Again, I can place like this also the compasses. I will get the dots like this. Then I will just take this one, join this one. So like this, I can find out the lines of forces around a bar magnet. This is how we have made the lines of forces, and this is how we have made the lines of forces, which is originating from the north pole and going away, and it is coming towards the south pole. This is the representation of magnetic lines of forces. Magnetic lines of forces. So here you can see this is the normal bar magnet we are using. There you can see we have drawn the magnetic lines of forces. This is U-shaped bar magnet or horseshoe shaped bar magnet. This is where north pole and south pole is kept. We know that north and south poles are going to be attracted each other. So attraction is from there. North and north or south or south. Same poles are going to be repel each other. That is also shown there. Here you can see that there is no field lines. That is called a repulsion. That region is called a repulsive region. Okay, now if you look at these figures, you can see that the density of field lines are less at the middle and maximum at these poles. The density or the number of field lines are less at the ends and maximum at the very less at the middle and maximum at these two ends. And where these magnetic field lines are more, when the density of the magnetic field lines are more, the strength of the magnet or the power of the magnetism will be more. So we can say that when we are traveling from the poles are having maximum power or maximum strength. When we are traveling from the pole to the middle, at the middle the field lines are missing. So we can say that at middle the property of magnetism will be almost zero. The magnetism will be almost zero. Now, the next one, the last point what we have to discuss today is the properties of magnetic field lines. So now we understood that around the magnet there is a region where we can find out magnetic forces, and this region where we can experience magnetic force is called magnetic field. Now we know how to trace out or we know what is magnetic lines of forces. That means a diagrammatic representation. The diagrammatic representation magnetic field is represented using a curved lines is called magnetic lines of forces. Direction is there. Always it will be originated from the north pole and it will be going to the south pole, and we know how to plot this using a bar magnet and a magnetic compass. The last portion is the properties of magnetic lines of forces. The first one is that magnetic lines of forces are closed continuous curves. Magnetic lines of forces are closed or continuous curves. Their lines of forces are continuous curves. The second one is that outside the magnet, the lines are traveling from north pole to the south pole. However, inside the magnet, it will be traveling from the south to the north. Outside the magnetic lines of forces are traveling from north pole to the south pole, and inside the magnet it will be traveling from the south pole to the north pole. And third one is that no two lines of magnetic lines of forces are intersecting each other. That means they will not come and collide each other, they will not come and intersect each other. No two field lines are going to be intersect each other. The third one, fourth one, densely populated lines of force. That means where there is more number of lines of forces, there will be the strength of the magnet will be maximum. Where there is less number of forces, the strength of magnetism will be minimum. And the last one is that magnetic lines of force show the direction of the magnetic field at each point around the magnet. We know that we have got the direction always in this traveling. Outside the magnet is from the north pole to the south pole, and inside the magnet it will be from the south pole to the north pole. Very, very important, these 5 properties. It's a sure question for the annual exam. So, what are the properties of magnetic lines of forces? These lines of forces are continuous curves, and outside the magnet, these lines of forces are traveling from begin from the north pole and finishes with the south pole, and inside the magnet it will be traveling from south pole to the north pole, and these magnetic lines of forces never intersect each other. And the fourth one is that where there is more lines of forces are there, there will be the maximum power or the strength of the magnet. Okay, and the last one we have discussed that the direction of the magnetic field also can be found from the diagrammatic representation. So this is very, very important portion. Activities 6 and 7 is also very, very important. What you have to do is you have to write on a white paper these 5 properties and you have to learn. Now the last portion today is Earth as a magnet. Earth as a magnet. Already I think we have studied about the directive property of the magnet. Is it not? Directive property of the magnet. In directive property, what we have seen that a freely suspended bar magnet always points north-south direction. It will give north-south direction. How it is lying in that same particular direction? It is also depending upon the opposite poles are going to be attracted each other and same poles are going to be repelled each other. And we know that natural magnets are existing on the earth. That means what is natural magnets? Just like stone pieces, just like rock pieces, naturally we are able to get natural magnet. That means inside the earth magnetism is there. Inside the earth magnetism is there. And you know, if you dig a small pit and if you take an iron piece there, bury the iron piece there, and if it is in the north-south direction, after maybe 6-7 days if you take it out, then that iron piece will become a magnet. That means earth is having magnetizing power. Okay, so how the earth is going to get this magnetizing power? So in order to understand that, the scientists have they have an imagination that earth has a hole. We are actually, if we consider the hole, inside the earth a big magnet is buried. All the magnetic properties of the earth, we are considering that inside the earth there is a big magnet is buried. In which direction? What will be this one? That means, no, this is the north pole and this is the south pole. That means we are just given. Now, when we are freely suspending a bar magnet, it is lying in north-south direction. That means we know that when we are freely suspending a magnet, suppose if it is north pole here and south pole here, what will happen? Same poles are coming, then what will happen? It is going to be rotated. It will be rotated automatically. It will come south pole here and north pole. The north pole here and south pole here. That means we have already learned that like poles are going to be repel each other and the unlike poles are going to be attract each other. So on this basis, this is actually geographic north pole and this is the geographic south pole of the earth. Okay, so if we are considering the geographic north and geographic south, how the magnet inside the earth is buried near to the geographic north south pole and near to the geographic south north pole. This is how magnet or the properties of earth we are considering. Now, on the surface of earth, if you freely suspended any bar magnet, how it will lay? It will be lying in this direction. That means just like this will be like just that means this is the magnet, this one the magnetic axis and this is the normal here. So there is a change of geographic north and the magnetic south pole. This is the magnetic south pole and this is the geographic north pole. There is a change by 11 degree. By 11 degree, there will be a change. 11 degree change will be there. Now, you just imagine, when we are freely suspending, what will happen? Our magnet will be like this. In which way? This will be the north pole and this will be the south pole. Because only the opposite poles will be attracted, similar poles are going to be repelled. So the difference between the geographical and magnetic axis is around 11 degree. This is the geographical axis, this is the magnetic axis. The difference will be around 11 degree. And since the earth is having the property of the magnet, that's why we are able to find out the direction using a magnetic compass. A freely suspended magnet always gives north-south direction. Like poles are going to be repel each other and unlike poles are going to be attract each other. So earth has a magnet. And on way number 87, there is a small portion is there. That means check your progress and you have to complete. Very simple. Three questions are only there. Fill in the blanks. You can complete it. So you have to read it very well. What is the homework? On a white paper, write properties of 5 properties of magnetic lines of forces and study it very well. Complete the check your progress on page number 87. If there is any doubt, you can contact me. Thank you.